69, Saxon Algebra 2, gas law problems. And you're saying to yourself, wait a minute, we've already talked about this whole ideal gas law. 1v1, T1, this weird equilibrium thing that happens between pressure and volume and temperature in a bunch of units that I don't understand, but they always stay in balance. And so we do these two-step problems where we, no, these aren't the two steps, sorry, where we just set it, we put all the variables in and solve for whatever's missing. You're right, we have done these before. We've seen this formula, it's all familiar. However, when we did these before, John used easy, cute, simple little numbers, and now he's taken off the training wheels, and now we have to use the kind of numbers that you actually would get, which are big, icky, scientific notation numbers. But here's the thing. We just practiced in the last lesson how to use our calculators to calculate these big numbers, and we also practiced the estimating part of it. Oh, there comes the headache, that whole remember to estimate before you calculate. So all this is another exercise and using our calculators to simplify the numbers. The other part of it, the sciencey part of it, it's exactly the same. Nothing's changed. So let's try it. 69.1. Okay, there's our formulas right in front of us. And I'm going to write the variables down here. P1, V1, T1, and I'm going to skip a line because some of these get kind of big and freaky. So I want some white space in between them. Okay, a quantity of an ideal gas had initial pressure, volume, and temperature values. Pressure, volume, and temperature, okay, we're in the same order, of 40 times 10 to the 4th atmospheres, 0.0003. Do you see what's happening here? Times 10 to the minus 6 pressure, and 700 times 10 to the 4th kelvins. It's all in scientific notation, you guys. And my exponents look too big. Just remember, I'll put a line underneath to remind you that they're exponents. Those are the first three. Ready? We have to keep going. Find the final temperature. Okay, so this is the question mark. I didn't do this. Find the final temperature if the final pressure was 0.0004 times 10 to 15 atmospheres, and the final volume look at those numbers. And then it says something interesting. Begin by solving the equation for T2. Okay, so what John is saying is this is going to be a whole lot easier if we don't have to move these numbers around to solve the algebra part of it. It'd be a lot easier to do algebra with just the formula than it would be with all these big, heavy, horrifying looking numbers. So that's what we're going to start doing, is rearranging the formulas to get the variable we want by itself. So I'm going to recopy. There's the variable we want to have by itself. And again, you know how to solve abstract equations, so this isn't hard. The first thing we'll do is cross multiply. We'll get P1, V1, T2 on one side, and then we'll get P2, V2, T1. You could change the order of these however you wanted within these three streams. I just keep PVT, PVT, and then notice that the sub numbers are different. Okay, T2 is the one I want by itself. So I'm going to divide away those two. Same thing on the other side. That cancels. So my new formula is T2 equals, and I'm going to be really careful, P2, V2, T1 over P1, P1. So we used our abstract algebra solving techniques to get the desired variable by itself. So now all we have to do is don't have to do any swimming with our big honky numbers. All right. I'm just checking to make sure that it's correct, and it is. Yay. Okay. So, and we could do that for any of the variables, couldn't we? Going back here to our original formula, we could have picked any one of these to be the desired variable, just like in any other abstract equation. So don't let this part scare you. We just made it easier on ourselves. So now I'm going to copy this to the other side. T2 is what we're looking for. Now that we have that, we're going to plug in those values, that are on the other side of my page. How annoying. Here we go. I'll get them out of the book so I don't have to flip. I'm putting my exponents really high so that you can see those. I better still put that little underline so that you know what the heck that number is. And then on the bottom, 40 times 10 to the 4th. Okay, there's our actual problem. The first thing we have to do now is estimate. Okay, 1, 2, 3, 4. So this would be 4 times 10 to the minus 4, right? Because we want that number to get smaller. So this would be 4 times 10 to the 11th. This one, 1, 2. So it would be 1.5. We'd round that up to 2 times 10 to the negative 2. That becomes negative 16, right? Negative 2 and negative 14. And this one, 700. 7 times 10 to the 2nd. And then there's the 4th, so it's 7 times 10 to the 6th. Excuse me. And then this is all over. Here we go. This is 4 times 10 to the 1st. So the 1 and the 4 gives us 5. And then 1, 2, 3. That's 3 times 10 to the minus 3. So it's 3 times 10 to the minus 9. Okay. I'm just double checking my numbers against John's step so far. I wish I had you here with me to correct my answers. John has this last one as 3 times 10 to the negative 10. One, 2, 3. Well, I think he's wrong. So, let's see. We've got 4 times 2 times 7 over 4 times 3. These cancel. We get 14 over 3. And that is going to be 4-ish times 10 to the 11 minus 16 plus 6 minus 5 plus 9. Wow. So it's 11 plus 6 plus 9, that's 26, minus 21 equals 5. Okay, so that's our estimate. John is off by a power of 10 from us. His estimate is 35 times 10 to the 5th, which is not a proper estimate because there should only be 1 there. So this should be 3.5 times 10 to the 1 times 10 to the 5. This should be rounded up. It should be 4 times 10 to the 6. So this is John. This is me. So that's off by a power of 10. So that intrigues me. I'm going to be careful as we do that. Then, so I see this. I'm not quite sure. I'm pretty confident with my estimate. This is the one that was different. John right here had 3 times 10 to the minus 10. That was John. I think he's wrong. I like mine better. Okay, so now what we're going to do is we're going to take our original calculation, which I've written all over, so now it's a big mess, and we're going to run that through the calculator. Oh my gosh, that's a lot of do it using parentheses. Grind it through, and the final answer that John gets is 3.5 times 10 to the 6. That's the calculator answer. Now, ours was 3.5, let's see, where is it? Oh, it was 4 times 10 to the 6. Okay, I feel really, this is my estimate, right? 4 times 10 to the 5th. I'm a little high here and I'm 1 low there. I still like it. John's is also very for John. Okay? I'm going to look and see if I can figure out where the difference is. But our answer was quite, given this whole mess, so I feel good about that. John's answer is even closer. Still don't know how he got it. But you guys can see that this is all about the estimating. I'm sorry, it's kind of a mess. Good luck with it. Text me if you need help. That's lesson 69.